Hello guys, you're welcome back to CS Arena Academy. My name is Bakri Razak Abolaji. I'm one of the tutor in CS Arena Academy. You see, in today's class, we are going to be taking a look at uniformly accelerated motion. For those of you that have been following me from the beginning of this class till now that we've gotten to this stage here, if you are just new to my channel, you can watch my other videos on motion, distance and displacement, and also my videos on speed, acceleration and velocity. So in today's class, we're taking a look at uniformly accelerated motion. Before I started today's class, let me try to introduce something. If you are new to my channel, please take a look at the subscribe button that is found below here. Just try to click on the button below and subscribe to this my channel. And I promise you that at the end of this video, I'll be showing you how I managed to score 90 plus in my physics in jamb, and how did I do it that I'm able to limit my time that is given to us, and I'm able to solve physics for just only 30 minutes, and I completed my calculation. I'll be showing you with example of how I solve physics altogether. Now, so giving an example on each of this topic will tell you, okay, this is how you can go about physics at the end. Now, the first thing I need to know, that you should know that this series that we are talking about, that we are doing here, is mainly for the jambites, the jamb students, and also some of you that will be taking an examination such as what AP physics exam in abroad in UK, or you are taking an examination such as what WAEC. This tutorial will also be what's applicable to you. Now, let's start with this. The first thing is that what do you understand by the word uniform? Let me try to break this physics down into something that is really simplified. I want to talk about uniformity. Uniform simply means something is what's equal. It is constant or true. For example, now we can say the area of this shape here is uniform. No, this shape here is a kind of a rectangle. A rectangle has a uniform shape. Compared to if I have the area of this here, take a look at this. This is a shape that looks like a frustum. Altogether, a frustum has a kind of a variable dimension. The dimension here is bigger than the dimension in this. That means diameter in this place here is bigger than the diameter in this place here. Automatically, this shape here is a non-uniform shape. Why this one has an equal dimension? Look at the diameter here will equal to the diameter here. Then this one is what? A uniform shape. So when we said uniform simply means in layman language, simply means constant. Something is constant. Now, what about uniformly accelerated motion? Uniformly accelerated motion is simply is a kind of motion that has a constant acceleration throughout. But the question I'll be throwing to you today altogether is that what? Does a uniformly accelerated motion, does it really exist in real life situation? Actually, we have a greater example of uniformly accelerated motion. You get something now? But even though the best example that we know is that, so in real life situation, this kind of motion is an assumption. It does not really exist in motion, in life. You get something now? So we assume that there's some motion that they are very close to uniform, in which the acceleration is constant altogether. So when we say uniformly accelerated motion, simply means the motion that has a constant acceleration. Example of this kind of motion that we are assumed to have a constant acceleration. Why? Because the acceleration is very close to constant. Is the motion under gravity. Motion under gravity is an example of a uniformly accelerated motion. Now, this motion under gravity, what does that mean by motion under gravity? Sorry, let me try to complete it. What do you mean by motion under gravity? Take for instance, assume I have a ball that is found on this top of this thing here. If this ball tends to drop downward, this ball here will be dropping at a constant acceleration. Now, because the ball will be dropping down under the influence of gravity, simply means it will be pulled down by gravity. So the acceleration of the ball will be constant throughout, but not something that this gravity that we're talking about is not always constant all through the motion. Altogether, the gravity that we are referring to here does not is not constant throughout the motion. It simply means there are some variation in the gravity. Take note on something here. Because of the non-spherical nature of the Earth. We know that the Earth is non-spherical. Now, we can have the equator altogether. Let me say this is my equator, and I also have what? The pole. Now, not something that was gravity at the pole is different from the gravity at the what? Equator. Altogether, it simply shows that what, even though on the earth, the gravity is not what? Equal. So, to say uniformly accelerated motion does not really what exist, but we assume there are some motions that are very close to uniformity. So, we assume that they are what? Uniform. So, the best example of motion that is close to uniformity is the motion under what? Gravity. Are we together like that? Now, today, what we are going to be looking at is the what? We are going to be taking a look at equation of uniformly accelerated motion. Altogether, the equations of uniformly accelerated motion. Now, you see, normally we have we have what? 4 equations of uniformly accelerated motion. 4 equations of what? Uniformly accelerated motion. Now let's take a look at the equation one by one. I will be explaining some basic things here so that it can cover different syllabus for students that are taking different examination. Altogether. Now take a look. The first equation of uniformly acceleration is being defined from here. You know, when we talk about acceleration, acceleration itself simply means the rate at which the velocity of the body is changing. Please, if you want to know more about this, you can refer to my video that I did on acceleration, velocity, and speed. Altogether. Now, acceleration is the rate of change of the velocity of the body. Now, we know that the velocity of the body changes. Let me assume that what? The final velocity of the body, let me take it as what? V final minus my initial velocity of the body as what? V initial, VI, VF minus VI. Altogether. Now, if you are in another country that you are not in what? You are not from Nigeria, please note something that what? They can assume that final velocity is taken as VF and initial velocity as VI. But if you are in other country like USA or the other, we can assume, in other country you can make use of this, but in Nigeria, we can use what? V as my final and my U as my initial. So I'm not employing this today so that you understand what I'm saying. So whenever I add VI and I use what? U, I'm simply talking about the same thing as what? Initial velocity, final velocity. Hope you are following up with what I'm doing here. Now, we know that my acceleration is equal to final velocity minus initial velocity times what? Time taken. So this is the rate of change of what? Velocity. Now, you know when we said change in physics? Change in velocity simply means the final velocity minus initial velocity. That was what we mean by what? Change in velocity in physics. Altogether. So the rate at which this velocity is changing with time gives rise to an acceleration. Now, the acceleration of the body now can easily be written like this. I can write this equation, let me say this over 1, can have this as Vf minus Vi to be equals to acceleration times time. Altogether, now from here, I can easily make my final velocity as the subject of formula. If my final velocity is taken as the subject of formula, I'll be having my initial velocity as Vi, which is positive. I take it to be positive. Then plus acceleration times time. Now, this is the basic equation of uniformly accelerated motion. Now, you know I said earlier on that uniformly accelerated motion is a motion with a constant acceleration. This is showing that what? The acceleration of the body here will be constant. So if this is my equation 1 for uniformly accelerated motion. Now, the second equation of a uniformly accelerated motion is given like this. If I assume that the total distance covered by a body, please note, total distance covered by a body is always equal to the average velocity of the body, altogether multiplied by the time taken. That's the total distance that you cover, that a body will cover. When a body starts, a body that is moving in the uniform uniform motion, total distance that will be covered by the body will be equal to the average velocity of the body multiplied by the time taken for the body to complete that motion. Now, take a look at this. I'm using my x. Okay, let me use this x here to represent my distance. X to represent my distance altogether. This x represents my distance along the x-axis. If I want to represent my distance along the y-axis, I can use y. This y will represent my distance along the y-axis. Y-x represents our distance along the x-axis. Altogether. Now, note something about this distance that is here. Okay, so my distance, my total distance covered by the body is always equal to the average velocity of the body multiplied by the time taken. All together. Now, what is my average velocity for this body? The average velocity of this body will be equals to, let me say, the initial velocity of the body, let's use VI, plus my final velocity of the body, all over 2. This is average. You know, if you have two numbers, let me say I have 2 and 3. The average of this number will be equals to addition of the two number divided by the what? The 2. All together. Now, from here, I can have this as my average multiplied by time. So whereby I can easily say that the body might not even start from the origin. Note that. That is the confusion that a lot of us always make. Now, if the body is starting from the origin, then I can have this as my what? My total distance. But note that this distance that I wrote here, this x, is simply final distance minus initial distance. Are you getting me? But please note, every motion, we assume that the body is starting from the origin, from rest position. If the body is starting from the rest position, that means the initial distance of the body will be equal to 0. Altogether, so I can easily rewrite this equation, but if the body is not starting from rest position, then this initial distance will not be equal to 0. Altogether, so the distance that we are having here is my final distance, whereby I can easily remove this off. Now, I'll be having my x to be equals to initial velocity plus final velocity all over what? 2 altogether multiplied by time taken. Oh, sorry, I want to replace this. So this can be what? Sf minus what? Si. Altogether, this is my what? This. But please note that this Sf minus Fi represents what? X. So for those of you in Nigeria, altogether, I would like you to understand something here that what? I can also represent this X as this equation S. You know, in some time we replace our own X as what? S. S is equals to what? V. Sorry. Our initial velocity is replaced by what? U. And my final velocity is taken as what? V. All over 2 multiplied by what? Time. Please note that these equations are the same. These are the same equation. So I can write it as what? X equals this. Or I write as what? S equals to what? U initial plus final over 2 times what? Time taken. It's representing what? The same equation. Why? I can also write this one as V equals U plus AT. I'm still using the same what? Equation. V equals U plus AT. Just that I'm only making use of initial velocity as U and final velocity as V, so that I will be able to differentiate between my initial and I'll use the later to differentiate between initial and final altogether. So this one is done like this. This is what? The total distance covered by a body. If you have to calculate for the total distance covered by a body, and you are given the initial distance, you are given the initial velocity, the final velocity, and the time, you can easily apply this equation altogether. Now, let's take a look at the next equation, which is the third equation of motion. Now, for my third equation of motion, from the first equation of motion that we have, you know, I said, taking a look at this, let me try to make use of this. If this my x, I'll get something now. Please note, you know, I said this s is what? Your final x minus what? Initial. That's what round up to give rise to this. Now, this my x is equals to initial velocity plus final velocity all over 2 multiplied by time taken. Now, if I come to equation 1, in my equation 1, you know my final velocity is equals to initial velocity plus acceleration times time. I can replace this and give me what? This is my x, sorry, I want to use this. My x is xf minus si, final distance minus initial distance give rise to displacement. Please note that. To get displacement, this is displacement. This is simply initial position, final position minus initial position give rise to this displacement. Altogether. So from here, I can have this thing like this. My VI, initial velocity, plus my final velocity is now, my final velocity is this. Please, as I said earlier, you can use any of these that are representing the same. Altogether. So I'll be using the 2 so that I will not confuse some students. Now, my final velocity is this, vi plus at. I'll be having what? Vi plus at. Please, this is my final velocity. Everything all over 2 multiplied by time taken. I'll be having what? Sf minus Si. Final distance minus initial distance. How you get something now? Equals to my vi plus acceleration times time all over 2 multiplied by time taken. Then I can have my Sf minus Si to be equals to 2vi, so initial velocity, plus at all over 2 multiplied by time taken. Then I can use this time to multiply all the numerator because these are the numerator. This is over 1. Then I can have my what? Sf minus Si equals to 2vi times time altogether plus at squared. That means t times d is 2vi times t. T times t is at squared all over 2. I'll be having what? Sf minus Si altogether. I'll be having I can easily separate this as 2vit over 2 plus 8c squared all over 2. Yeah. So to cancel this, I'll be having what? Sf minus Si, initial position minus final position, equals to what is my vi? Okay, that is vit plus this is I can easily write this one as half 8c squared. Half 8c squared. This is my equation of motion. This is my third equation of motion. If this is my second equation, altogether, this is also my second equation. Please note, I'm trying to use different letters so you get to understand what I'm saying better. Now, I can also write it for those of you. So if you are writing an AP physics exam, the equation will be written for you like this. We will be having what? Sf minus, if I take this one out, I have what? Si plus vit plus half at squared. Now, but for the jamb bites, for the jamb students that are going to write jamb exam or WIAC exam, any examination in your country in Africa, you can easily make use of this. We will be having the equation to be written. Let's come back from here. Now, when I gave the equation, I use this. X is equal to u plus v over t and divided by 2. I'll be having this s to be equal to u plus v all over 2 multiplied by what? Time taken. Then s can be equal to u plus, what is my v? My v is equal to u plus at all over 2 multiplied by time t. Then I'll be having 2u plus at over 2. Everything multiplied by time, where I'll be having what? 2ut plus 8c squared. This can be easily written as what? Over 2. Then my s will be equals to this divided by this. I'll be having ut plus this is half 8c squared. I know that some of you, this is the basic equation that you understand, that s is equal to ut plus half 8c squared. But don't forget that this s here is simply the displacement of the body. Displacement of the body. And normally, don't forget that displacement is a vector quantity, and displacement that is a vector quantity depends on two things. It depends on the initial and the what? Final. So displacement is always what? The final position of the body minus the initial position of the body. That's what this equation that I wrote here is simply all about. This one is all about the final position of the body equals to the initial position of the body plus initial velocity times time plus half times acceleration times t squared. So I have this as now what? Equation 3. This is the third equation of motion, which can also be this. For those of you that are writing jamb, this is my third equation of what? Motion altogether. So this is for the what? Physics exam that we have here. Now, let's take a look at let's look at what? The fourth equation of motion. I'm going to be using the same standard for the fourth equation of motion. Now let me try to remove this out here. Now, the fourth equation of uniformly accelerated motion will be here. Now, how do we get it? Taking a look at my displacement. My displacement s is equally the same thing as what? My initial velocity plus my final velocity all over 2 multiplied by my time taken. And then my first equation of motion is final velocity is equals to initial velocity plus acceleration times time. Now, I can make my time series formula from here, and I substituted into this equation. Now, if I make time series formula, I'll be having Vf minus Vi equals At. Then my T will be equals to Vf minus Vi all over A. Now, I can substitute back into this equation, and I'll be having X to be equals to Vi plus Vf. Vi, what is my Vi? Now, okay, sorry, my Vi plus Vf all over 2 multiplied by my T. My T is equals to Vf minus Vi all over A. Now, I want to do something that is kind of what? Simplified here. You know, in mathematics, if I have A plus B, it is still the same as saying B plus A in mathematics. Why? Because addition is commutative. Are you getting what I'm saying? In mathematics, addition is what's commutative. Now, from here, I can easily say that what? I can write this as my Vf plus Vi. Final velocity plus initial velocity all over 2 multiplied by Vf minus Vi all over what? A. Now, you know, this is numerator, this is numerator. I can easily separate this as Vf plus Vi multiplied by Vf minus Vi all over what? 2 multiplied by A, 2A. But how do we go about this one here? Now, Vf Vi. Now, take a look at this. If you have A plus B and you have A minus B, we normally call this thing what? Difference of what? These are difference of two squares. Are you getting that? This thing is being gotten from difference of two squares. So you are having the same thing. The only thing that differentiates this number in mathematics is the positive and the negative. I can easily say that what? A multiplied to what? A and B multiplied to B. There I'll be having A squared, and then the sign will multiply to the sign. So A times A will give me A squared, plus times minus will give me minus, B times B will give me B squared. This is difference of what? 2 squared. So from here we can easily replace this as Vf times V will give me what? Vf squared, plus times minus will give me minus, Vi what? Vi squared all over 2A. Then I'll be having my X to be equals to Vf squared minus Vi squared over 2A. Let me try to remove something off here. I can remove this one for you. Sorry. So we are having take Vf squared sort of formula, but Vf squared minus Vi squared equals to 2ax. Now, this is what we are going to have here. But if you take a look at this x here, we can say that what? This x here, you know, I said my x is x final minus s initial. That is the final position minus initial position. So you can write like this, and then my final velocity square will be equals to what? My initial velocity square, that's plus 2a sf minus what? Si. All together. So for those of you that will be writing what? AP physics exam, I think we are going to be what? Having this as your final velocity. Right? For those of you that will be happy and that will be writing the other exam that are either your jamb or WAEC altogether, this thing will be what? Into this. Now let's take a look at this one here. Let me try to rewrite the equation with the one that we know, the way I normally do this. Now from here, you know my s will be equals to u plus v all over 2 multiplied by time. And if I assume that my equation is v is equals to u plus at, then my time taken from here can be equals to v minus u over a. Then my s will be equals to u plus v over 2 multiplied by v minus u over what? A. So from here, you know, you can easily write this one as v plus u because it's addition all over 2 the same way. Then v minus u all over a the same way. I'll be having s, and my s will be equals to v times v square minus u square over 2a. Then cross multiply. I'll be having v square minus u square equals 2as Then my v square will be equals to, bring this here, I'll be having u square plus 2as. Now, this is the equation of what? Uniformly accelerated motion altogether. So this is the fourth equation. As this is also the what? The fourth equation. Now, note something about these two equations that they say. Just that this s here, my s here is dividing sf minus si. I mostly try to what? Explain this because a lot of students, when they are reading questions that they are reading textbooks that are different from their what country, they seem to get confused. Are you getting me? Why? Because of the kind of what notation that they are using in their own country. Now, in this place here, majorly I know that the Nigerian students, they make use of this in majorly most of their textbook, that x as displacement. But when you get to abroad, altogether, most of your the textbook that they use abroad, they make use of the full displacement, this thing, that we know that displacement is change in position of the body from the final to what? Initial position. Altogether. So, my generalized equation of motion are this. Let me try to write out the whole equation of motion that we have. Now, okay, let me wrap up this. Now, my generalized equation of motion, I'm going to put it into what? Two formats, which are also of the same kind. My equation of motion, equation 1, I think I have Vf equals to what? Vi altogether plus AT. That's my equation 1. For other this thing, which can also be written as what? V equals to U plus AT. My equation 2, I think I have xf minus xi equals to vi plus vf all over 2 multiplied by time, which can also be written as s is equals to u plus v all over 2 multiplied by what? Time t. This is my what? This. And my equation 3, I think I have xf equals to xi plus vi t plus half at square, which I can also use what? Write as s is equals to ut plus half at square. Please, if you are following from the beginning, you will not understand what I'm saying here. Then from here, the last equation, which is vf square equals to vi square plus 2a brackets sf minus si, which is the same thing as saying v square is equals to u square plus 2as altogether. Now, these are the four major equations of motion altogether. Now, in some countries, they call this in the big four. I get something now. Some use these as the big five because they include one last equation to it altogether. Now, these are the equations of uniformly accelerated motion. If you watch here, I'll be explaining. I promise you that I'm going to be explaining to you how this equation, how I make use of these things in jamb, and I was able to take 90 plus in my physics exam. Altogether, I'll be showing you how I normally use this. Now, the secret behind this equation, there's some secret that is found behind this equation that you need to know. Now, you see, if you are given a question and to solve using this equation, please note something. There's something that I'm missing here that we need to know. Now, there's some secret that is found here. You see, equation 1, if you notice this equation 1, and sorry, if you notice audio equation, you notice that audio equation has 4 quantities in them. The first quantity that is found in the equation is acceleration, A. The second quantity that is found here is final velocity. We also have about initial velocity, and we also have about distance, and then we have displacement. And the last quantity that is there is time taking. And each of this equation has 1 or 2 of these quantities. Now, if you take a look at equation 1, you notice that what we found in equation 1, we have the final velocity, the initial velocity, the acceleration, and the time. The final velocity, initial, acceleration, and time. Equation 1 is missing one thing, which is distance. It simply shows that what, if you are given a question, you need to look at what is missing among these 5 quantities. If you understand what is missing among these 5 quantities, then you can easily know the equation to use. Please note, at least 4 of the quantity will be given to you and 1 will be missing. And that is found in all this equation altogether. So if the distance is missing, know that that question you are meant to apply equation 1 to solve. V is equals to the one that does not require distance. Altogether, if you read the question very well, you notice that, oh no, there is no distance in this place, even though you are not even asked to find it. Altogether, but if the acceleration is missing altogether in the question they are given, then you have to apply this average velocity, that distance, total distance equals average velocity times what? Time. Altogether, because it is this one that does not have acceleration. Why? If there is an omission of final velocity, which is v, if final velocity is missing, then we can easily use this. You notice that well, this equation does not have anything like final velocity v. Now, why the last equation can only be used when there is no time taken. Now, I've been able to cover each of the quantities that is here. But please note, everything, all your equation must start with an initial velocity. Altogether, that's why you notice that what all the equation has initial velocity. Initial velocity can never be missing in a question of motion. These are the secret behind what I used to get my 90 plus in physics. So the first thing I do before I tackle question, I don't just solve question. I look at the question, analyze the question, write out the variables that I seem to be missing from the question. Now, when I notice that okay, this is the variable that I'm missing, then I can easily solve for the variable. But if I know okay, in this question, the variable here is not what's missing, then I can let me just try to analyze and find another variable to it. Altogether like that. So when I read the question, I bring out all the variables that is given to me in the question. Then I go, okay, I know that this question is under motion. But which equation of motion am I to apply? Then I will need to think, okay, what is the question about? What are we given there? What am I asked to find? I get me. So if I could know all this, then I can easily eliminate I can easily do what I want to do and eliminate altogether. Now this is a likely question that I'm given here. Take a look at the question that is here. They said a car that is initially traveling at 10 meters per second accelerates uniformly for 4 seconds at a rate of 2 meters per second squared. Now, he said the first thing I do before I tackle question in exam is that I need to fish out the variable that is given to me in this place here. Altogether, what are the quantities that I'm given here? The first thing, read the question from the start. They said a car that is initially traveling at 10 meters per second. Note something. In an exam, they might change this question. Whenever they said, sometimes they might say a car that is initially traveling from rest. Here, they never made mention about rest. They just said that the car is initially traveling at 10 meters per second. That means the car is having an initial velocity because whenever you see meter per second is the unit of velocity. Now, they say it is initially traveling at 10 meters per second. That means the initial velocity of the car has been given to you as 10 meters per second. But if they don't give you initial velocity, they might check the car is initially traveling from rest. When they say the car is starting from rest, it simply means that car also have an initial velocity, but in that case, it will be equal to 0. That is when it said from rest. But here, they've given us that it is traveling with an initial velocity of this. They said the car accelerates uniformly for how many seconds? 4 seconds. Shown that the time taken for the car to accelerate is 4 seconds at a rate of 2 meters per second. Sometimes I use the unit to understand the quantity given. Rate of 2 meters per second squared. This is 2 meters per second squared indicating acceleration. Now, the acceleration of the body is equal to 2 meters per second squared. Now, what are we asked to find? It's like in a straight line. How far does the car travel during this time? Whenever they use the word how far simply means what is the total displacement of the car? What is my value of x, or what is my value of x? S. What is the total displacement of the car? How far simply means the displacement of that car. Altogether. So how do we get? I'm looking for what? S is what's missing, or we just say I'm looking for x. I mean, my s and s are the same. You got what I'm saying? Now, how do we solve this? If you watch this here, these are the quantities that I'm giving here. This is what I'm asked to find. Then which equation am I going to assign? I need to assign the equation of motion. You know, I said we have 5 quantities that are there in all the equation of uniformly accelerated motion. Now, I will need to assign an equation that is having only U, T, A, and S altogether. One thing is missing here. What is missing? Final velocity. It simply means the equation I'm going to be applying must not be having anything like V. So which equation does not have anything like V in this place here? The only equation that we can apply here is S equals UT plus half AT squared. Why? Because it does not have anything like V. Are you getting what I'm saying? Because we know they have to find this S, which is the displacement, or X altogether. So from here, I can easily say my U is 10 multiplied by my time is 4, then plus half, then multiplied by my A. My A is was 2 times my time is 4 squared. So let's try to use some mathematics here. 2 here, 2 cancel this has gone. I'm left with 16 there. So 10 times 4 will give rise to 40 plus 4 squared. You know, I'm left with 4 squared here, which is what? 16. So 40 plus 16 will give rise to 56 meter. Now, I've been able to what? Analyze this question in just seconds. By understanding, I want to use the equation of motion, but what am I given in the question? If I know what is given in the question, I need to eliminate what is not found inside the what? What I'm given, what is the quantity that is missing there? Then that quantity that is missing, I need to find a equation that does not have that quantity. Then I can use that equation to solve. All together. So please, now this is how I manage to score high in physics in my jamb, and I'll be showing you how we can do that in other topics in physics. All together. Please, if you are new to my channel, click on the subscribe button to subscribe to my channel, and also like and share my video with your friends. Please, because your like will give me our upper edge, and it will make my video to be shown to other people so that they can also watch this simplified physics. So if you are paying for UTME exam, you are in the right place. I'm going to show you all the tricks in passing your UTME exam for the next year 2023. Thank you for watching this video. Do have a nice time. Don't forget to subscribe and click on subscribe and the like button to like my video. And please note, if you have any question that you want to ask me, maybe you have been finding it difficult, drop a comment for me in the comment box section below. I'll be waiting to receive your comment and then give an answer to that. Thank you very much. Thank you.